Hi, this lesson is about the chain rule. The chain rule is used to find the derivative of a composite function. So before we present chain rule and use it to find a derivative, let's just remind ourselves what a composite function is. Composite function is a function of a function. And these are two different notations that are often used to demonstrate a composite function. It's read as f of g of x. So first, let's practice just using this notation. Suppose you're given f of x equal to the square root of x minus 4 and g of x equal to 3x plus 2. And we want to find f of g of x. That means that g of x is the input into f of x. So 3x plus 2 will replace the x in the f of x function. So that's exactly what you see here. I have the square root of g of x minus 4, and then in the next line I replace what g of x is equal to, so I have the square root of 3x plus 2 minus 4, and then finally combine like terms, 2 minus 4, and that gives you the square root of 3x minus 2 is the value of f of g of x. If I do this composite in the other order, g of f of x, that means that f of x, which is the radical, is the input into g of x. So that replaces the x in the g of x function. So that means that when you do that, you will have 3 times f of x plus 2. And when you replace what f of x is equal to, your g of f of x is what you see here, 3 times the square root of x minus 4 plus 2. You can't do anything else in that case in terms of combining like terms because the minus 4 is inside the radical and the plus 2 is outside the radical. All right, so let's continue practicing this type of notation. We want to identify the outer and inner functions of the following composite functions. Now, the inner function will be whatever you evaluate first in terms of the two functions, and the outer function will be whatever you evaluate last. And that will be important when you actually use chain rule to find the derivative. So here I have, in part A, x cubed plus 2x minus 4, and that polynomial is raised to the 4th power. So in this case, the inner function is the polynomial, and the outer function is raising it to the 4th power. In part B, in order to identify your inner and outer function, you should first rewrite it so that you don't have a radical and it's not in the denominator, which is really the first thing you would have to do in order to find the derivative. And once you do that, you get 3 times 2x squared minus 4x raised to the negative 1/2 power. Now 3 is the coefficient, so that is just going to get multiplied by this composite function. And in this case, your inner function is 2x squared minus 4x, and your outer function is raising it to the negative 1/2 power. Now let's talk about a trig function. Here I have y is sine of 3 theta. Now in this case, your inner function is 3 theta, and your outer function is sine. So imagine if you had a value of theta. Let's say theta is, suppose you let theta equal pi over 2. So what would you do if you knew that theta is pi over 2? First, you would plug it in here to theta. Then you would multiply it by 3. That's the first thing you would do. So that's your inner function. Then you would take the sine of 3 pi over 2 and evaluate it. And so that means that sine is your outer function. So you need to think about order of operations when you're considering which one is the inner and which one is the outer. Here's another trig function. This is cosine squared of t. In order to identify inner and outer function, it might help if you rewrote this in a different way. Cosine squared of t means the same thing as cosine of t to the 2nd power, which means in order to evaluate something like this, you would first evaluate cosine of t for whatever the value of t is, and then that value would get squared. So your inner function is cosine of t, your outer function is squaring the cosine of t function. Okay, here's another one. We have y equals e to the 5x. In this case, 5x is the inner function, and then e is your outer function. So you would first evaluate 5x, whatever x would be. Let's say x is 1. Multiply it by 5, that's your inner function, and then you would evaluate e to the 5th power. All right, here's another one for logarithms. I have ln of t squared plus 1. In this case, t squared plus 1 is your inner function, and ln, or your natural log, is your outer function. Okay, in part G, this one's a little bit more complex because composite functions could have more than just an inner and outer function. You can have multiple layers. And in this case, I have 3 layers. So I have tangent cubed of 2x, which means the same thing as tangent of 2x to the 3rd power. In this case, what would you evaluate first? First, you would evaluate 2x for whatever x is, as long as it's in the domain of tangent. You would multiply 2 times x. Then you would take the tangent of that, so I'm going to call that the middle function. And then the tangent of 2x, at that point you would then cube it, and so to the 3rd power is your outer function. All right, so now that we understand composite functions, we're going to present our chain rule. So suppose g of x is differentiable at x and f of x is differentiable at g of x, then the composite function f of g of x, which I'll call capital F, is differentiable at capital F, and therefore f prime, capital F prime, is f prime of g of x times g prime of x. So in other words, you take the derivative of the outer function first, and then you multiply it by the derivative of the inner function. So again, understanding outer and inner will be important for you to be able to do this properly. And that's if you have 2 functions. We'll talk about if you have more than an outer and inner. In other words, 3 or 4 functions, what would you do? So let's talk about just an outer and an inner function. So I have y is equal to the square root of 2x plus 7. So whenever you have a radical, you want to make sure you first rewrite it without the radical, which is what you see here. Y is equal to 2x plus 7 to the 1/2. And then you want to evaluate the composite function. Or take the derivative of the composite function. So applying chain rule means that you take the derivative of the outer function first, and the outer function is raising it to the 1/2. So that's what you see here. It's 1/2 2x plus 7 to the, and then subtract 1 from the exponent. So it's to the negative 1/2. And then times the derivative of the inner function, and the derivative of 2x plus 7 is 2. Then you simplify, the 2's cancel, and so you get 2x plus 7 to the negative 1/2, which is the same as 1 over 2x plus 7 inside the square root. Okay, so let's do another one. We want to find the first and second derivative of the function 2x of sine of 2x. And then we want to evaluate at least evaluate the second derivative at pi over 8. All right, so first, this is a composite function where your outer function is sine, your inner function is 2x. So your derivative, your first derivative, is the derivative of sine of 2x, which is cosine of 2x, times the derivative of the inner function, which is 2. So f prime is 2 cosine of 2x. Then I need to find f double prime, which is the second derivative. So first you take the derivative of cosine of 2x, which is negative sine of 2x, times the derivative of 2x, which is 2. But when you multiply it by the 2 on the outside, your second derivative is negative 4 sine of 2x. And then we evaluate it at pi over 8. So you plug in you plug in pi over 8 in for x. So you have negative 4 sine of pi over 4. And we know that is negative 4 times root 2 over 2. Cancel. And so you end up with negative 2 root 2. Okay, let's do another one which requires us to use chain rule. We want to find the derivative of pi cubed over the square root of 1 minus 3x. All right, so the first thing you need to do is rewrite that radical in a different way. So this is the same as pi cubed 1 minus 3x to the negative 1/2. Now, I can apply chain rule. Remember, pi cubed is just a number, so it's a coefficient of the composite function. So you're going to apply chain rule just to this part, and whatever the chain rule gives you is going to get multiplied by pi cubed because it's just a coefficient. All right, so my outer function is to the negative 1/2 power, so that's the first thing you do. You have negative 1/2 times the pi cubed times 1 minus 3x, subtract 1 from negative 1/2 to give you negative 3/2, times the derivative of the inner function, and that is negative 3. Okay, so when you multiply all of the coefficients together, that's the negative 1/2, the pi cubed, and the negative 3, you see what you see on this next line, which is a coefficient of 3 pi cubed over 2 times 1 minus 3x to the negative 3/2. And if I rewrite 1 minus 3x to the negative 3/2 in a different way, you'll get 3 pi cubed in the numerator over 2, and this gets rewritten as the square root of 1 minus 3x raised to the third power, positive 3 power, because the whole thing came down to the denominator. All right, so here's another function. We have r equal to 2t cubed over the cube root of 1 minus 4t. So I have another radical in the denominator. So you can handle this in one of two ways. Either you can apply quotient rule to this whole thing because it is a quotient of two functions where your denominator requires you to use chain rule just like it did in the previous example. Or you can apply product rule to this function by rewriting this as a product, which is what I did. So I rewrote r as 2t squared times 1 plus 4t to the negative 1/3. So again, the radical got written as an exponential expression, and by bringing that up to the numerator, I now have a product. And a product means that you have to use product rule on these two variable expressions. So if I let f equal 2t squared and g equal 1 plus 4t to the negative 1/3, 1/3, sorry, this is a capital T, not a lowercase t. Then f prime is 4t and g prime is negative 1/3, 1 plus 4t to the, and then subtract 1 from negative 1/3, which when you subtract 1, that'll give you negative 4/3 times the derivative of the inside function, which is 4. Okay, so that's my g prime. All right, so here I did f g prime plus g f prime. So, actually I wrote it as f prime g, which is the same as g f prime. And then when you multiply the 4 and the 2t squared, as well as the negative 1/3 here, you have this, you have negative 8t squared over 3, and the 1 plus 4t to the negative 4/3 gets written as the 1 plus 4t to the positive 4/3 in the denominator. And the second product gets written as 4t over 1 plus 4t to the 1/3. Okay, so now that I see those two different denominators, I can see that I need to find an LCM. And the LCM is going to be this one right here. 3 times 1 plus 4t to the 4/3, which means this one has to get multiplied by 1 plus 4t to the first power, or to the 3/3 power, so that you can add the exponents. And when you add 1/3 and 3/3, you will get 4/3 as your exponent. So that gives us negative 8t squared plus, and then here you can actually multiply these. So that'll be 12t times 1 plus 4t to the first power, which is the same as 3/3. And the denominator combines into our common denominator of 3 times 1 plus 4t to the 4/3. Okay, so now I have this line right here, and I can now go on to the next line because I can then distribute the 12t to the second binomial. So you have negative 8t squared plus 12t plus 48t squared, which means that you can combine like terms. So you get 40t squared plus 12t. And then you can either leave it like that, or you can factor out a common factor from the numerator, which is 4t. So you get 4t times 10t plus 3 over 3 times 1 plus 4t to the 4/3 power. So these last two rational expressions are equivalent. Nothing cancels, so either one of the last two answers are fine. Okay, so here we want to find the slope of the tangent line to the curve of y equals 2 tangent squared of t at t equal to pi over 4. Remember, the slope of a tangent line to a curve is a derivative, and this derivative requires you to use chain rule because tangent squared of t is a composite function. So just to remind you that tangent squared of t is the same as tangent t to the second power, and in this case 2 is just a coefficient. So when I apply chain rule, you have to take the derivative of the outer function first times the derivative of the inner function. And then 2, just this 2 here, just gets multiplied by that derivative, which is what you see on the next line. On the next line, when I take the derivative dy dt, you'll get 2 times tan of t, because you have to multiply 2 times this 2 and then subtract 1 from the exponent, so it's just to the first power, times the derivative of tangent, which is secant squared of t. So that gives us 4 tangent t times secant squared of t. And that's your general derivative. Now you have to plug in pi over 4, which was given in the original problem. So you get that the slope, or dy dt, is 4 times tangent of pi over 4 times secant squared of pi over 4. So when you evaluate tangent and secant squared at pi over 4, you'll have 4 times 1 times 2 over root 2 to the second power, which gives you 4 times 1 times 2 squared. 2 over root 2 is just 2. And then when you square that, you will get 16 as a final answer. So the slope of the tangent line to the curve is just 16 at pi over 4. Here we need to find the equation of the line. to the graph of y equals sine of 4t at t equal to 3 pi over 2. Here's another composite function. And so your composite function is sine as your outer function, 4t as your inner function. So when you take your derivative, you're going to have to use chain rule. But I also need a point in order to find the equation. So the first thing I did was evaluate sine of 4t at 3 pi over 2. So that is the sine of 6 pi, and sine of 6 pi is 0. So your point is 3 pi over 2, which is equal to 0. Okay, so now that I know my point, I'm ready to find my derivative, which again, I have to use chain rule. So the derivative of sine is cosine. The derivative of 4t is 4. So you have 4 cosine of 4t, which then when you plug in 3 pi over 2 in this line, you will have 4 cosine of 6 pi. And the cosine of 6 pi is the same as cosine of 2 pi or cosine of 0, which is 1. So that is a slope of 4. So when you use your point and your slope of 4 into the point slope formula, you get y minus 0 equals 4 times x minus 3 pi over 2, which gives you y equal to 4x minus 6 pi as a final answer. Okay, so let's move on to another example. Here we want to find f prime of x for f of x equal to secant cubed of 2x plus 1. So again, if I rewrite this in a different way, just to make it more obvious what your layers are, this is the secant of 2x, the whole thing is cubed, which means that your outer function is the 3, or the cubed, your middle function is secant, and your inner function is the one that you see right here, 2x plus 1. So when you're using chain rule, you have to work from the outside towards the inside, meaning first take the derivative of the power, so power rule. So we have 3 secant squared of secant of 2x plus 1 raised to the second power. Then times the derivative of secant is secant tangent, which is what you see here. Secant of 2x plus 1, tangent of 2x plus 1. And then times the derivative of the innermost function, which is just 2. The derivative of 2x plus 1 is just 2. So there is like a couple things you can do to simplify it. So the 3 and the 2 multiply together to give you 6 on the next line. And then we have secant of 2x squared and the secant of 2x here. That becomes secant cubed of 2x. And then finally, your tangent of 2x. So your final answer is what you see in the box. Right, so it is possible to have more than an inner and outer layer. In this case, we had an inner, a middle, and an outer, and you start with the outer function first when you're taking the derivative, and then you take the derivative of the middle one, which is this part here, and then finally the derivative of the innermost function, and then simplify anything that is possible to simplify. Okay. So in this next example, we want to find y prime and y double prime for another composite function, and this is e to the negative 2x. E being the outer, 2x being negative 2x being the inner. So y prime is e to the negative 2x, that's your outer derivative, times the derivative of the inner, which is negative 2. And so y prime is negative 2 e to the negative 2x. When I need to take y double prime, you're still taking the derivative of e to the negative 2x using chain rule, but negative 2 is now a coefficient, so it gets multiplied by anything that you take the derivative of. So y double prime is going to be negative 2 times e to the negative 2x times negative 2. Again, this is your outer derivative, this is your inner derivative, and when you combine the negative 2's, you get that y double prime is for e to the negative 2x. Okay, so let's do another one. There's lots of examples we can do for chain rule. Here's another example of a composite function that has an outer, a middle, and an inner function. Outer function is sine, middle is cosine, innermost function is x squared. So we remember we work from the outside towards the inside. So the derivative of sine is cosine of, and then the inner part stays the same as cosine of x squared, times the derivative of the middle function, which is cosine, and that is negative sine of x squared, and then times the derivative of the innermost function, which is 2x. The derivative of x squared is 2x. And then we can multiply the negative in front of the sine and the 2x to give me negative 2x. I'll put that in front. And then times cosine of x squared times sine of x squared. And that's all you can do with it. You can't simplify anything else. All right, so here we want to evaluate f prime of 2 for f of t equal to e to the 3t over t squared. So this is a quotient, so I'm going to use quotient rule, but within quotient rule, I have a composite, which is e to the 3t. So I have to apply chain rule to the numerator of e to the 3t. So my f is e to the 3t, my g is t squared, my f prime, which is where we apply chain rule, is 3e to the 3t, and here it's just power rule. Derivative of t squared is 2t. All right, then we plug that into our quotient rule. And remember, with quotient rule, you have to start with gf prime first, which is what you see on this line. So it's gf prime minus f g prime all over g squared, which is t squared to the second power. So here on this line, I factored out a t, and when you square the denominator, you get t to the fourth in the denominator. So that leaves us with t times 3t e to the 3t minus 2 e to the 3t. Then this t on the outside cancels with 1t in the denominator, which leaves us with t cubed in the denominator and 3t e to the 3t minus 2e to the 3t in the numerator. And then we can substitute in our value, which was 2. So f prime of 2 gives us what you see here, 3 times 2, e to the 3 times 2 minus 2 e to the 3 times 2. So we get 6 e to the 6 minus 2 e to the 6 over 2 to the third power, which is 8, which is what you see here. And then you have like terms in the numerator, so I have 4 e to the 6 over 8, and the 4 and the 8, well, they cancel to give you just a 2 in the denominator. And so you have f prime of 2 is e to the 6 over 2. And that's an exact answer. You would leave it like that, only round and use a calculator if you're asked to round to a particular place value. Okay, so this is a little bit more abstract, but it still requires that you use chain rule. You want to evaluate capital F prime of 0, given that capital F of x is equal to f of 3 times f of 4 times f of x. So here we have actually 3 layers again. This f here is the outermost layer. This one in here is the middle layer, and this one here is your innermost layer. So in order to evaluate this, you're also using this information. You're given that f of 0 is 0 and f prime of 0 is 2. All right, so in order to find f prime of 0, we first have to find f prime of x, which is what I'm doing here. So f prime of x is equal to f prime, remember you work from the outside, f prime of, and then you have the innermost part, which is what you see above, times 3 times the derivative of the middle function, f prime of 4 of f of x, and then 4 times the innermost function, which is 4 times f prime of x. Remember, the coefficient just comes along with the derivative. All right, so now I'm ready to substitute 0. So just be careful with the notation. And so all of the x's above get replaced with 0 in the second line. And then I start replacing what f of 0 is equal to and f prime of 0 is equal to. F of 0 is 2 and f prime of 0, f of 0 is 0 and f prime of 0 is 2. All right, so that's what you see in this next line. I replace f of 0 with 0 and f prime of 0 with 2. So you're left with what you see here, f prime of 3 times f of 0 times 3 times f prime of 0 times 8. And that, again, if you just keep simplifying, you finally end up with 2 times 6 times 8, which gives you a final answer of 96. All right, so that was quite a few problems with where we used chain rule, as well as an example of where we used chain rule within product rule and chain rule within quotient rule. But it is possible to use product rule or chain rule within product rule or product rule within chain rule, etc. It can get more complex as you get more complicated functions. All right, so give the homework a try. Good luck.